My name is Saswata Mukherjee. I'm from the DSC web team, and in this online session, I'll be taking you through the basic aspects of Git and GitHub and how to use them to your advantage. So let's get started with Git. Git is an open source distributed version control software. Now let's break down what that means. A version control software, or VCS, is a software which keeps track of all the changes made in a certain project and builds a history over time. Thus, imagine if you've messed up a file in your project and now your project no longer works, and Control Z isn't an option. With a VCS, you can revert back to the last working version. Git is also a distributed VCS, which means that it will not only maintain the history of changes on a central server, but will also have a copy on your local machine. Now, there are some other VCSs such as Subversion and Mercurial, but Git is by far the most used one. We will also be taking a look at GitHub. GitHub is an online platform maintained by Microsoft which provides hosting for our version control software. It provides all the features of Git plus a lot more. It helps organizations maintain their code bases efficiently, open source projects to exist, and allow developers to showcase their portfolios as well as contribute to open source. So let's get started by first installing Git. First, let's check if your system already has Git installed. Run the following to verify. So if you have an output like mine, Git is already present in your system and you don't need to follow the next part. Otherwise, proceed. So installing Git will vary with the OS that you're on. If you're on Windows, head over to git-scm.com. And from there, grab the latest XE file and run that. Running that will set up an installation wizard, and with the default option selected, install Git. Make sure to select the options for Git Bash, as that is something that we'll require later on. Now, if you're on a Linux-based operating system such as Ubuntu, open up your terminal and type in the following. Now, since I'm on a Mac, I'm not going to run that, but if you're on Linux, on a Linux-based operating system, go ahead and run that. Now, if you're on a Mac like me, the easiest way to install Git would be to install the Xcode command line tools. To do that, let's run the following command. Now, running that will install the Xcode command line tools, and with that will install Git. So I'm not running that since I already have Xcode command line tools installed. So to verify an installation on whatever operating system you're on, again run git ---- version. Now you should see a similar output. Congrats, you have Git on your machine now. Alright guys, let's talk about the basics of Git first. A Git repository is basically a database where all the changes have been stored. It tracks all the changes in save points over time. When Git is initialized in a directory, a new folder is made called .git, which is hidden. This contains the repository. Deleting this would result in deletion of the entire history of the project. Now, a Git repo can be obtained in two ways. Either a local directory can be made into a Git repo, or an existing repo can be cloned from elsewhere. Now, there are a few terminologies that you need to keep in mind. A working directory is the present directory in which all of the files of the project are stored. The staging area is an intermediate level where the files to be saved in the repository are first added. Now, multiple files can be added to the staging area. These files will then be pushed to the repository. Committing refers to the act of pushing the files from the staging area to the repository. A commit basically creates a checkpoint which stores a certain version of the files in a project. If any changes are made, then the files need to be added again to the staging area and committed to the repository. This will create another checkpoint with a newer version of the files, and so on. And we can also push our local repo in our local machine with all the commits to a remote server such as GitHub, or pull changes from it. Now, branches are a very important feature of Git. It is basically a copy of the repo which can have separate changes. The default branch is known as master branch. So let's say you wanted to add a new feature or fix bugs in a project which may risk in you messing up the repository. Or if you're collaborating with someone on a project who is working on one feature whilst you are working on another, both of you will not be able to commit at the same time. Thus, via branching, you can work separately without messing up each other's code. After finishing work on a branch, we can merge it to the master branch. So let's go ahead and see all of this in action. Okay, so fire up your terminal. Now this tutorial is on a Unix based terminal, so if you're on Windows, you might prefer using something like Git Bash, which you installed earlier, or a terminal emulator of your choice. So let's start with making a new directory. Let's call this directory git_tutorial, and let's cd into that directory. Well, initially, since if you have done a fresh install of Git on your system, you need to configure the Git tooling. So you type in the following. And instead of name, type your own username or your complete name. And what this does is give your commits an author. So your name will appear only on your commits. After executing this, again, let's configure the email tooling so that the author also has an email for your commits. So I'm not going to execute these commands since my tooling is already configured, but you should. Alright, so let's initiate git in our directory by typing git init. And as you can see, an empty git repository has been initialized at the path. Now I'm using omyzsh, so I can see where git has been initialized, and I can also see the name of the branch that I'm currently at. This might not appear for you, don't worry, that's not a fault of yours. So let's start by first trying to find this .git folder, which is hidden. So if you type ls, you should probably see that folder, but you don't. That's because it's hidden, right? So we need to type in ls-a, and this will show us that .git is a folder, is the hidden folder, and that's already there. Alright, cool. So now let's try and explore the features of this version control software. So let's make a new Python file, vi test.py. Now I'm using Vim. You might use a text editor of your choice, but make sure that the directory that you save your file to is this git_tut directory. So I to insert, and let's keep it simple. Let's print hello world and escape, and let's save this file. Now as we know that to commit in Git, we need to first add all the untracked files to the staging area and then push it to a commit, right? So let's first check what's in our staging area at the moment. To do that, we have to type in git status. So right now it shows that we are on branch master, there are no commits, and the untracked file test.py, which we just saved, is there. So now the untracked means that the test.py file is not in the staging area right now. So let's put it in the staging area by typing git add test.py. Okay, so now my file should be added to my staging area, but this is not a very convenient way of adding files to staging areas, since you might have multiple files, so you can't execute all those commands one by one, right? So instead we are going to type git add space dot, and what this does is it adds all the files present in the directory to the staging area. So let's execute that as well, and then let's type in git status again to check. Now you can see that the changes to be it has changed to changes to be committed, and there's a new file test.py which has been added to my staging area. So right now we're going to do our first commit by typing in git commit -m, and this -m flag specifies that you need a commit message. So for a commit message, let's type in initial commit. Good, right? So let's press enter, and as you can see that the file has been committed. So how do you verify what commits you have, or how do you see your commits? That's using git log. So when I enter, look at this. So this first commit has the name initial commit, and this is known as the command hash of that particular commit, right? The author is Saswata Mukherjee, who is me, and my email. This is picked up from the configuration tooling that we just executed, and it also has the date and time. So for some terminals, this opens up a text editor, and you need to quit that text editor by pressing the Q key, which I'm going to do. If not, fine. So let's change the file and commit again. So open up that file, vi-test.py, and instead of print hello world, let's keep that there, and instead we'll add two variables. So b equal to 1, and then we'll print the sum. So let's again save that file, and there we have it. So now let's add that to a staging area again. Check the staging area once it's been added, and this time it's modified instead of new file. And now let's commit it, and I'll call this second commit maybe. Cool. So let's look at our commits again, and this time the second commit shows up with another commit hash, right? Alright, so let's press Q to quit, and let's clear the terminal once. So now what we're going to do is that we're going to mess up that file. So let's say vi-test.py, and instead of, I don't know, maybe I produce a lot of syntactical errors like so, and save that file. So now my file no longer works, and Control Z isn't an option, and I need to revert back to the last working version. So how do we do that? So what we're going to do is we're going to visit our git log once, and from that we're going to copy the commit hash of the second commit, right? So press Ctrl C and then exit, and what we're going to do is we're going to write a command, git checkout, and what this does is we're going to paste the commit hash, and then minus space the file that we want to revert. And what this will do is that it'll revert my test.py to the last working version. And now you can see, if we visit test.py once again, it's perfectly fine. It's the second commit version that it already was. So let's start with branching. So clear your terminal, and what we're going to do is we're going to create a branch. So for that, let's first see what all branches are already there. For that, type in git branch, and as you can see, we are at the master branch, and there's a star pointer beside it which specifies that yeah, we are in fact in this master branch, our default branch. So press Q to exit, and then again let's make another branch. Let's name it first, and now another branch has been created. So if we type in git branch again, we should see first, and we are at master, right? So let's switch our branch. So to do that, what we'll do, we'll type in git checkout again, but this time we'll specify the name of the branch. So git checkout first, and now we switch to first, and as you can see, my master over here has changed to first. So in this branch, let's make a few changes to our test file. So open Vim again, and what we're going to do, we are going to add a couple more print statements. So let's say I make a string with, I don't know, something, and print s over there, and we'll save this file. So cool, we've saved this file. Let's add it to our staging area, and then let's commit it. But what we're going to do, we're going to make the commit message our third commit message. So git commit -m third commit, and now there's another commit. So if we view git log right now, we're going to see 3 commits, but at the last commit, which is a third commit, there's a commit hash, but the head pointer is pointing to first instead of master. This means that this commit exists only in the master branch, only in the first branch, not in the master branch. So to verify that, let's exit, and let's change our branch again to master, and then let's view git log again, and we'll see there are only 2 commits, the initial commit and the second commit. There is no third commit. So how do we get the first branch commit in our master branch? Well, that's using merge. Alright, so with merge, you need to keep 2 things in mind: the branch that you're on and the branch that you want to merge. So right now I'm on the master branch, and I'm going to merge the first branch, right? So I need to type in git merge first, and what this command will do is that it will merge the first branch commits into the master branch. So let's execute that and see, and you can see that something happened. Test.py now has one file change and 2 insertions. So let's view git log again, and there you have it. We have the third command right over here with the head pointing to master, but it came from first, and you can view that over here. It has its own commit hash, third commit. Awesome. So let's quit from here, and now I have finished developing stuff in my first branch, so I want to delete that branch. For that, the command is git branch -d first, and what it will do is it will delete this branch. So my branch is deleted. So now if I type in git branch, I only have master. So alright, so let's clear that. And now this was a very simple example. So imagine you're working in an organization, and your main development branch is the master branch, and you have two other branches, namely git branch, let's say bug fix. Alright, and you have another branch where you're developing a particular feature, so git branch feature. So now you have two branches, so let's visit them and look at that. And yeah, we are currently at master right over here, and feature and bug fix are two branches. So let's say you are going to independently develop a certain feature on the feature branch. So you check out to feature, and over there you maybe you add a newer file. So let's say instead of test.py you add test2.py, and over there you print let's say new feature. So that's what you print over there. Let's save that file, and now we'll add that to staging area and commit that as feature. Great. Now simultaneously somebody else is developing a bug fix. So for them they'll git checkout to maybe bug fix, and what we'll do is that they'll maybe they're changing something in test.py. Sorry. Test.py, and maybe the value that we are supposed to print isn't 2 but is rather 4, right? So that's what they changed. Now they're adding it to their staging area, and they're committing it as a bug fix. Let's say bug fixed. Great. So now if I go back to my master branch has none of these commits, right? So what I'm going to do is I'm going to first merge in the bug fix. So git merge bug fix. Now once I did that, my master branch, if we look at git log, has the bug fixed commit inside it, right? But my feature branch does not have that commit. So to get that commit inside my feature branch, I have to rebase. So to do that, let's go to checkout. Let's go to our feature branch, and from there let's use git rebase master. And what this will do is it will unwind our feature commit and will apply that after the latest master commit. So now if we press git log inside our feature branch, we will see both the bug fixed and the feature commits, right? So awesome. So let's instead go to our master branch and make sure our feature is now available inside the master branch. So go into master and then simply git merge feature. Sorry, feature. Amazing. So now our master branch has all my new files. It has our bug fixes, it has everything. If we check git log, we have the bug fixed commit as well as the feature commit. So awesome. You now know what is Git, and now let's move on to something a little bit more interesting, which is GitHub. Alright guys, so head over to github.com and let's sign up for a new account. So let's give in the username. I'm giving git session. So it's taken. So git session SM. Alright, for the email address, let me give, yeah, so the S here, and for the password, okay, so make sure to make it capital. Alright, and let's scroll down and verify. So, and let's create an account. This is a small little thing that they ask for. Let's just complete setup over here, and the verification mail should arrive. Let's verify, and your GitHub account is set up. Now I already have a GitHub account, so I'm not going to use this one. So this is my GitHub, and let's create a new repository straight away. Let's name it Git Sessions, and you can fill in a description here if possible. I'm going to keep this private. Also, for these three options, let me tell you what they are. So a .gitignore file, let's start with that first. It's a file that specifies what files or folders in your project that you might not want to put under version control, simply because those files are easily or automatically generated in your project. So for instance, let's say you're working on a node project. So your node modules folder does not need to be put under version control, simply because you can just generate it again via npmi through your package.json. A readme, okay, so a readme file is a file that introduces and explains your project. It should have a description and should provide instructions on how to use and install your project. And these files are usually written in a formatting language known as Markdown. And finally, a license is used to make your GitHub repository truly open source, so that people can use your project, change it, as well as distribute it as their own. So I generally default to the MIT license. So anyway, we don't really need any of these three for now. So let's just create a repository. And there you have it. We have a new repository. Alright, so as you can see, there are a bunch of instructions right over here. So let's just copy this remote add thing. I'll explain what that is in a second. And as you can see over here, I've made a new directory, and I've initialized a Git repository over there. And let's just run this command. And what this does, it's adding a remote server for our GitHub, for our repo, and that remote server is hosted by GitHub. And the remote server can be referenced by this keyword known as origin. So using this, what we can do is we can push code using git push -u origin master. So let's just make a new file right over here, just test.txt, and I'll just say hello, save that, and we add that to our staging area, and we commit that as our initial commit. And then what we can do is we can push this newly generated code, this newly generated text file, to our remote repository using this command, git push -u origin master. And this will insert it in the master branch of the remote repository. So as you can see, it's done. So if we go back over here and refresh the page, what we should see is a test.txt file right over here. Now what we can do is we can add a readme. So let's add one over here, simply in this browser window. Let's just say git sessions. Alright, and we can write hello world maybe. And what we can do is we can commit this new file directly, and we have a readme. But see, now this remote repository is one commit ahead. This has two commits, while our local repository only has one commit. If we check git log over here, it only has one commit. So what we can do is we can pull whatever new commits there are from the remote repository to our local repository using the git pull command. So it has pulled, and we can see it's pulled a new file known as readme. So if we type in ls, yeah, in fact we have to pull that thing, and this is necessary every time you push. It's necessary every time you push new pieces of code to always run git pull, since you never know when the code might change inside that repo. So there, okay guys, so what we can do is we can also clone certain repos that we either find cool or that we want to work on, and we want to clone it for our local machine. So we can do that by pressing this button over here, and that can allow us to either download a zip file or just simply gives us a link which we can copy and run the command git clone space that file. So that will clone into my repo, and now we have that repo inside our local machine. So if we say go cd go web lookup, and now alright guys, so the last two features of GitHub that we're going to learn is forks and pull requests. So let's head over to the first contributions GitHub repo. So search for it, and we get the repo. Here we go. And this is the repo that helps beginners to start contributing to open source. And over here, as you can see, there's a button labeled fork. So a fork is a unique GitHub feature which allows you to make a copy of a public repo, including all branches, and then make changes to it without affecting the original repo. So let's do that. And I'm going to fork it. So, and now it takes some time. There we go. We have our fork of the repo, and what it allows us to do is just write our name here. So let's add a name. This is a big file, and let's add a markdown name over here, editing this file. So I'm just going to add my name. Sorry. There we have it. So now let's just commit the changes. There we have, and we are making changes on our fork, but this isn't reflecting changes on the original repo, which is this one right over here. Now what we can do is we can go to this original repo and we can make a pull request. So let's make a new pull request by going to the pull requests tab, and a pull request is a method of submitting contributions to an open source project. Right, so it occurs when a developer asks for changes to be which are committed to an external repo to be included in the main repo. So let's make a new pull request, and we can do compare across forks, as you can see right over here. And I'm going to select my fork of the repo, and it will automatically compare the changes that there are. So there we go. Now it's able to merge, and we can create a pull request right over here. So I can say updated contributors.md and make the pull request. I'm not going to do that, but you can go ahead and click that as your first pull request. So there you have it. You now know how to operate Git and GitHub. So thank you guys for watching this video. Kindly like, share and subscribe for more awesome content. And if you have any doubts regarding what was taught, you can contact me via Twitter, Instagram, GitHub, where my handle is Saswata Mukherjee, or on LinkedIn, where I am Saswata Mukherjee. Thank you.